Hi everyone. So in our last module, we learned about one way between subjects ANOVA. And today we're going to talk about an extension of that, which we call one-way repeated measures ANOVA. So if you'll remember in our last chapter, we talked about between subjects one-way ANOVA. And with between subjects one-way ANOVA, we were comparing the means of three or more independent samples. And the reason that we call it one way is because we were only interested in one dependent variable. So if you remember back to the example that we used in that chapter, we were calculating a between subjects one-way ANOVA by looking at associations between educational attainment and age at birth of first child. And you'll remember we had three groups of people. So we had folks who had a master's degree. We had a second group of people who had a bachelor's degree. And then we had a third group of people who had a high school diploma. And we were interested in the mean age at birth of first child of each of those three groups. And what we found is that for those people who had a master's degree or higher, their mean age when they had their first child was 31. For those who had a bachelor's degree, their mean age when they had their first child was 28. And then for those who had a high school diploma or less, their mean age was 25 when they had their first child. And so overall, what we saw is that as the amount of education that you have decreases, it looks as though your age when you have your first child also decreases. And so it wasn't a big effect, it was a modest effect. But what we did, in addition to sort of coming up with a graph like this, we did an actual statistical test called the Between Subjects One-Way ANOVA to see if that effect was actually statistically significant. And again, we're only looking at one dependent variable here, so that's why it's a one-way ANOVA. So last time we did what's known as a between subjects ANOVA, but now what we're interested in is a within subjects ANOVA, and we also call this a repeated measures ANOVA. And the repeated measures ANOVA is actually just an extension of the paired samples t-test. Now you'll remember when we do paired t-test, we have two dependent samples, but with repeated measures ANOVA, what we're looking at is still dependent samples, but this time we're looking at data where we have three or more dependent samples. And I'll give you some examples of the difference. So now what I want to do is talk about the ways in which we might use the repeated measures ANOVA and contrast it with what you've already learned about the paired samples t-test. So if you remember, one of the ways that we can use the paired samples t-test is to look at the same group of cases, but to collect data about them at two different points in time. So for example, let's say we have a group of people and we're interested in their blood pressure. We might collect blood pressure data from that group of people at time point 1 and again at time point 2. Mostly seeing if we can see changes in their blood pressure over a certain period of time. And so in this case, we have the same group of cases, but we're collecting data at two different time points. And so under those circumstances, we would use a paired samples t-test. We can think about looking at these same cases and looking at changes in blood pressure over time, but instead of collecting data over two time points, we might want to collect data over three different time points. And so it's under that circumstance that we would use a repeated measures ANOVA instead of a paired samples t-test. So here we have the same cases. We're measuring them at time point 1, time point 2, and time point 3. Still asking the question, does blood pressure change over time? But now instead of having two time points, we have three, which requires us to use the repeated measures ANOVA. All right, let's look at another example. So one of the ways that we talked about using the paired sample t-test in the past is if we have the same cases, but we're trying to measure them under two different conditions. For example, before and after a treatment. So here's an example where we would use a paired samples t-test. In this example, we have 4 participants and their children who have ADHD, and we're measuring their levels of distraction. And so we're collecting data from them um, at 2 different points, either before they have ADHD treatment and again after ADHD treatment. So we have 4 participants, the same group of people, but we're measuring them under 2 different conditions, either pre-treatment or post-treatment. And because we only have 2 conditions here, we would use a paired samples t-test. So we could be interested in answering the same question, but instead of having data from 2 different conditions, we might have data from 3 or more different conditions. And so when we have data from 3 or more different conditions, we want to use a repeated measures ANOVA. So for example, we have these same 4 participants. They represent children who have ADHD, and we're interested in their levels of distraction. But instead of just doing a pre-post test, we collect data before they get the treatment, immediately after the treatment, and then maybe we collect data again at 6-month follow-up. So 6 months after they've gotten the treatment. So because we have 3 different data collection points here, we can't use the paired samples t-test. Instead, we have to use repeated measures ANOVA. All right, let's look at another example. So one way that we could use a paired samples t-test is if we wanted to compare the weather in 2 different cities. So this graph is an example of trying to compare the average monthly high temperature in 2 cities, Cleveland and Erie. And so to graph this information, we basically have 2 data points that we're interested in graphing. We have the average high temperature in January, and then we have the average high temperature in June. So because we only have 2 data points here, we can absolutely use a paired samples t-test. We're talking about the same groups of cases, Cleveland or Erie, but we're collecting data at 2 time points. And so the paired samples t-test would be appropriate here. So let's say we still want to collect data on average monthly high temperature in our 2 cities, Cleveland and Erie. But instead of collecting data from only 2 months, we want to collect data from every month of the year. So we have 12 data points total. Because we have 3 or more data points, it's not appropriate for us to use the paired samples t-test. Instead, this is another example where we would want to use repeated measures ANOVA.